Not my chat. Yeah. Okay. Yeah. So hello everyone. Yeah.
Hello.
So I am actually dialing in from Singapore, whereby right now it's the rainy season right now, and well, apparently, according to some of the weather reports today, we had another incident of a minor flash flood again. So this is actually quite relevant to the topic that I am going to speak about today, which is rainfall really getting heavier? And we'd like to find out about that by building a weather forecasting pipeline using Singapore weather station data. Okay, so about myself, why am I interested in this whole topic? Because I'm a data engineer. I am based in sunny Singapore. Uh, uh, well, I don't really come from a very conventional background. I do have an aerospace engineering background as well as a computational modeling background. So, the if your weather is terrible, you have a lightning strike or something, then it's going to affect how your flights are going to be because that's going to affect the safety, whether you're going to have a lightning strike, whether the visibility is high or low, etc. And I'm not really when I'm not building pipelines, I I like to contribute to the community, and one of the ways which I contribute back to the community is by contributing to pandas, which is a library which I use pretty often, almost daily as a data engineer. And that's just one part of how I contribute. Uh, yeah, so I also contribute by speaking in these events like PyData Global, EuroPython, and so on and so forth. So, well, yeah, so today I'm going to talk about something that is very relevant to myself, which is about Singapore. Okay, so where is Singapore? So Singapore is actually 1 degree north of the equator and 103 degrees east, which is around here. Okay, so if you see that in this map, whereby we have Southeast Asia, and then you have see the equator line, and Singapore is just 1 degree north of the equator. So although we are in the northern hemisphere, but we are actually very, very close to the equator. And hence, Singapore is considered a tropical country near the equatorial zone. We're not, so we can, sometimes we call ourselves like a city state, island state, but we are definitely not a city or province in China, contrary to a lot of misconceptions. We're actually a country. And speaking of like countries that are in the equatorial zone, we also have our own 4 seasons that is based on the rainfall cycle. So right now we are at the season whereby it's cold and rainy. So we call this the northeast monsoon season. So during that period, we expect a lot more rainfall, heavier rainfall, and for prolonged durations. The temperature can get a bit colder, which is why I am nursing a bit of a cold right now. Yeah, so that's the northeast monsoon season, cold and rainy. And then after which we have a shorter season called known as the warm and dry season, which is actually towards the end of the northeast monsoon season. So that's somewhere around in February, March. So that's whereby they have less rain, it gets warmer. So at least that's according to official records. Afterwards, we have an extremely hot season whereby you just don't have rain and the temperature actually rises, sometimes to 35 degrees Celsius. And that is where we usually end up hiding in our air-conditioned rooms, trying to hide from the heat. And last but not least, we also have another season known as the Southwest monsoon season, whereby it's actually very hot and really very stormy. But that is actually when you have really heavy rainfall and you're going to have a problem of flash floods. Okay, so something like this. Okay, so some context is that this is actually a picture of rainfall, like a flash flood happening at Singapore's popular shopping district known as Orchard Road. So although we don't have massive flooding, we do have flash floods, also known as ponding. So this has actually happened in around 2010, 2011. And during that time, we thought that, one of our ministers said that, well, this is a ponding incident. It's not really flooding. And this is because of a once in 50-year rain. So this is a once in 50-year flood scenario. So we can't really do much to predict that. But what actually happened after that is that a few months later, we have another flood. And then subsequently, every year, we have more than one incidence of this type of ponding pretty much every year. And to put this into context, right? Since 2018, Singapore already had more than 20 flash floods. And according to our Public Utilities Board, they discovered that majority of the floods were not caused by any clogging or anything to do with the infrastructure, but it's actually caused by intense rain. So it's really something that they really can't do much about it. And it doesn't really help that since 2018, they've already improved their their drainage infrastructure. They've already dug more drains, improved their drainage system. They actually built Marina Barrage to store all the rain. And we are still having the problems of flash floods. That's because we don't really have a lot of land and we can't keep digging drains forever. So we need to find out a way to be able to predict how much rainfall we have to be able to manage our drainage such that we don't have flash floods. So this brings me to the question of, could we predict heavier rain with our weather data alone? Is that possible? If yes, then why are we still having this flash flood problem? But first, to discover that, we need to extract the weather data from the source. So in Singapore, we do have a culture of having open access to publicly available data. So for example, we will be able to access data about our economy, our population statistics, and most importantly, our weather, because we need to be able to plan our activities and plan according to the infrastructure around the weather. So having a real-time weather is very important for us. And for that, we have the data.gov.sg portal, which is an open data portal for people like us, people like developers, and pretty much everyone to be able to access the data and plan accordingly. And some key features about the real-time weather readings. It's a real-time API on the data.gov.sg API portal, and it's open government data that is available under the Singapore Open Data License, so that anyone can use the data as long as they are a developer or they're just using it for, it's not just about developers, but it can be used for commercial purposes. And last but not least, this API provides almost minute-by-minute weather station readings across Singapore. So why do I say almost minute-by-minute? It's because it's dependent on how, it depends on the granularity of the data collection for the weather readings. So for example, for temperature, we are able to take minute-by-minute readings. But for rainfall, it depends on your rainfall gauge, whether it is able to measure by minute or measure by 5-minute interval, or it really depends on the equipment that you're using, on the sensors that you're using. So as a data professional myself, I wanted to get my hands a bit dirty. So I decided, let's try to scrape weather data for a specific weather station, such that I will be able to compare my results with what the authorities use for their weather studies and climate studies. And And because you need to scrape multi-day data to be able to have a comprehensive weather study. So how about we scrape multi-day data from the API? So this use case is actually pretty different from what was really intended, which is for developers to report on the real-time weather readings at the point of time. So I will have to write my own script to conduct my own analysis. So when I look at the API, okay, so I see the request URL, I see the curl command, and then yes, okay, I have a request URL which I need to scrape the data. But when I try out the API and then I look at the data schema, I see that okay, the readings that I need is nested in a JSON, and that JSON is nested further in another JSON. And yes, it is a nested JSON format. So I will have to figure out myself how to extract that value that has been nested between a JSON and a JSON. And it's not as straightforward to extract it out using pandas alone. Because when I try to use pandas to just feed the whole entire request JSON into pandas, I end up having another JSON that's stuck in a column called readings, which means that I will have to extract whatever reading that I need into the data frame. So because I am a lazy person and I don't really want to rewrite the script all over again every time I want to scrape weather data. So I decided, okay, let's just write a script. And then when I want to get the weather data, I just run a script, and I'm not going to repeat it all over again because I want to automate things. So I created the script, and I put the code in GitHub. So yeah, so some design considerations that I had to think about when writing the script is that, okay, so I use the request library because request is like HTTP for humans. So I use the request library to get the to sort of send a HTTP request. And currently I'm able to scrape the weather readings from pretty much all the APIs that are supported. And I'm able to scrape them for continuous time range and for specific weather station. But well, although Singapore is pretty modern, but we do have some slow connection issues. So I have to account for that, and I have to retry my request when my internet connection is poor. And well, because the weather stations are maintained by people who will not be based at the weather station every day. So for example, if we have a public holiday like New Year's Day, you may not have any data. So I will have to pretend that there's data, but it's an empty data frame for that particular date, so that I won't have problems with handling the data. And because it's a nested JSON, I have to extract the desired station and readings and then try to stack them back with the timestamp that's associated with the reading. So something like this, the JSON in the readings column, I extract it out, and then I re-index it, and then I reset the index and concatenate them back. So I get back what I wanted, which is timestamp, station ID, value. And then after I'm done with this whole data pre-processing and automating the data pre-processing, that's where I start conducting the analysis. So this is actually the main crux of the whole talk, which is the Singapore rainfall data, a 4-year time series analysis. So this to compare my results with whatever climate studies or weather studies that Singapore the Singapore weather people have been using. I use the same weather station that they're using, which is the Changi weather station. So Oh, why do they choose that? Well, because it's probably a more convenient location to conduct the studies. And then the analysis time frame is from 2nd December 2016 to 30th November 2020. So that's about 4 years. And before we do any prediction, we need to understand the time series. So we need to abstract the trend and seasonality of the rainfall data, which in this case is 5-minute rainfall data using a 5-minute rainfall gauge. Okay, so the original data itself is actually a huge mess. So I decided that for my analysis, I'm going to look at what's going to be the daily sampling of the rainfall per day. Okay, so actually for Singapore, right, what we are interested in on the short term will be a 2-hour forecast. But then if you want to analyze what's the weather trend like, then it will make more sense to analyze it either on a daily basis or a monthly basis over time period. Okay, so when I look at the daily total rainfall, well, I can see that you can see certain spikes in here. But then one thing that I zoom in right now, zoom in at the instant is when I look at December 2019, whereby I have one particular day which have an accumulative rainfall of more than 140 millimeters of rainfall. In Singapore, if the rainfall is at least 70 millimeters, that is considered as heavy rainfall. And you have one day which is 2 times of heavy rainfall according to our definition. And this huge spike was not seen before that time period, before December 2019. So you can see that, okay, rainfall is getting a bit more extreme on a daily basis. And so I decided, okay, why not we look at the data on a weekly basis? Well, I can still see the same observations, and that your rainfall patterns of like on a weekly basis is actually getting more and more extreme. So if I look at 2016 to 2017, and I look at 2019 to 2020, I see that my like for 2019 to 2020, I have weeks whereby I have very little rainfall, like really very little rainfall and prolonged periods. But then I also see periods whereby I have extremely high volume of rainfall. This contrast is a bit extreme. Maybe I would like to look at on a monthly basis. Okay, so when I look at my data on a monthly basis, so I look at the total rainfall each month. Now, it actually follows a bit of a pattern, and it actually corresponds to what I have my perception of the 4 seasons in Singapore. But when I look at the data from 2019 onwards, I see that wait. How come on 2019 June I have very, very little rainfall? That's weird. And then why do I have quite high rainfall on 2019 May? And I look at the data from like a few years back. It's a bit weird, right? I mean, how can I have a month where I don't have a lot of rainfall? And it seems that there's a bit of a change in terms of the rainfall patterns on a monthly basis. Okay, maybe let's look at the number of rain days to have a better idea. Well, when you look at the number of rain days in a month, let's see that, wait, June, like 2019 June has more rain days than 2019 May. Wait a minute. So that means that the rainfall is actually heavier in May? 2019, that's very good. And then when I look at the pattern at 2020, and then wait. How come I have increased the number of rain days in May 2020? Wait a minute. So I categorized those months by the monsoon period that was defined by official sources. Let's see, wait a minute. May is not the monsoon season, it's actually inter-monsoon. And how come it has heavier rainfall than a month which is in a monsoon season? Does that mean that the monsoon actually came earlier? No, it doesn't. So the pattern actually is pretty strange, and like in recent years. Okay, so to be able to like have a better understanding in terms of time series characteristics, I use stat models of TSA to analyze and forecast time series. So stats models stats models library is a library for Python library for like statistical models, tests, and explorations. And TSA is actually a subset of stats models library, which contains concepts and functions for time series analysis. So if I can use TSA to be able to analyze most of the data, then probably I will have a good idea of whether the time series is good enough for forecasting. But before we decide whether it's meaningful to do a forecasting, we look at the stationarity and we also look at the patterns. And last but not least, we also need to look at the autocorrelation, which is the relationship between the time series and the lag version of itself. Okay. So when I did an augmented liquid filler stationary test, okay, it is stationary. It's stationary for daily and monthly. Okay, so looks good. And then I look at the moving averages. Oh, okay. Daily doesn't really look very promising. 7 isn't very promising either. Then 30 days seems pretty alright, except that I see that my data is getting like my rainfall is either getting very low or very high as time goes by. So if in particular we look at the time frame during the northeast monsoon season, whereby we see that when the previous northeast monsoon season, that was in 2019, you have extreme weather, you have more extreme rainfall. So for this monsoon season, is the rainfall going to be really high or really low? I have no idea, because if I look at the monsoon season for the previous years, it can go anywhere. So it seems that it's not going to be easy predicting the rainfall. When I look at the decomposition of the daily rainfall, I see that, well, there's a little bit of a trend, but not really. But at least it's not white noise. When I look at the monthly rainfall, it really becomes a little bit clearer that in 2019, like in the middle, there seems to be less rainfall, but then it seems to be increasing after that. So maybe there might be a chance to predict the rainfall. Who knows? And then I look at the autocorrelation of daily rainfall. That's whereby I think that is the hopes of trying to predict rainfall on a daily basis is not that high, because there's a low correlation between the daily rainfall and its own lag values, which means that I probably will have a hard time trying to predict it accurately. When I look at the monthly rainfall, it seems a little more promising, but maybe I will have to give it a try when I build my model. And now we recap the objective of this talk is that we'd like to find out whether we could pick heavier rainfall with weather data. So for this purpose, I decided to use ARIMA models for rainfall forecasting. because it seems that, the moving average is this. When I look at the moving average, it looks okay. And then there seems to be a little bit of like autocorrelation. So let's just try my luck. So what I did was I applied a rolling forecast tech on the time series data such that I will be feeding in each observation on a rolling window to improve my model. And then for the error metric, I'm using a root mean square. And objective is to minimize the root mean square error. And after that, I look for the optimized order parameters using some form of grid search, and then run forecast for the next end. So for daily forecast, it's going to be 60 days, and then for monthly forecast, it's going to be like the next 12 months. But when I try to run the remote model using the more optimized model, it seems that the observed prediction is very far from the predicted. That means that it's not predicting very well. And similarly for the monthly rainfall, although it's not as bad as that of the daily rainfall, but you can see that for January 2020, what was observed is unusually high, like in like 2019 December 2020 January is that for 2019 December it's unusually high amount of rainfall. And similarly for January, which means that somehow it's actually under predicting the rainfall during the monsoon season. And it's sort of hard to predict the rainfall, whether you're looking at a monthly basis or a daily basis. And so the key takeaway would be that with climate change, the rainfall patterns are actually becoming more extreme and more challenging to predict. Because you can see that suddenly with highest rainfall in the northeast monsoon season, and we seem to observe a higher than expected rainfall at inter-monsoon season, which also implies that whatever monsoon season that we're thinking about, which is associated with high rainfall, is actually arriving earlier than expected. And that implies that our rainfall patterns may have been changing such that relying on the weather readings may not be sufficient to predict rainfall. Yes. And so until we get more data and improve our sensors and our data collection, I guess I'm going to be expecting yet another flash flood like this month and this Christmas. Thank you, and do reach out to me by following social media, so Twitter, and you could also check out my project in my GitHub. So thank you.